Good morning class. Today we will further discuss about the topics of solid state, and we are going to discuss about the rules for the calculation of particles in a given unit cell. We are going to discuss about the rules for the calculation of particles in a given unit cell. So, next are the rules for calculation of particles in a unit cell. Rules for calculation of particles in a unit cell. So, there are basically 4 rules for the calculation of particles. There are 4 rules for the calculation of particles. The first rule states that if the particle is present at the corner, then it is shared by 8 particles, and hence its contribution is 1 by 8. If the particle is present at corner, then it is shared by 8 other particles, and hence its contribution is 1 by 8. Now, the next one is if the particle is present at phase center, then it is shared by 2 other particles, and hence its contribution is 1 by 2. If the particle is present at the phase center, then it is shared by 2 other particles, then its contribution is 1 by 2. The third one is if the particle is present body center, at the body center, then it is not shared by any other particle, and hence its contribution is 1. And the fourth point is if the particle is present at the edge center or end center, then it is shared by 4 other particles, and hence its contribution is 1 by 4. Let us see again. These are the rules for the calculation of particles in a given unit cell. If the particle is present at the corner, then it is shared by 8 other particles, and hence its contribution is 1 by 8. If the particle is present at phase center, then it is shared by 2 other particles, and hence its contribution is 1 by 2. If the particle is present at body center, then it is not shared by any other particle, and hence its contribution is 1. And the fourth point is if the particle is present at the edge center or end center, then it is shared by 4 other particles, and hence its contribution is 1 by 4. So, these are the rules which are used for the calculation of particles in different types of unit cells. Now, next topic is calculation of particles in different unit cells. Calculation of particles in unit cells, in different types of unit cells. The first one would be simple or primitive unit cell. The first one would be simple or primitive unit cell. In case of simple or primitive unit cell, let us have an arrangement of this. Let this be a simple or primitive unit cell in which particles are present only on the 8 corners. So, when we have to calculate the number of particles, we know that we have 8 particles at the corners, 8 particles at the 8 corners. So, the number of particles would be we have 8 particles at the corners and the contribution of one particle at corner is 1 by 8. So, 8 multiplied by 1 by 8 is equal to 1 particle. That means a simple or primitive unit cell has only one constituent particle, either it may be atom, either it may be ion, or either it may be molecule. It can be any one of the three. So, in case of simple or primitive unit cell, we have 8 particles at 8 corners, and the contribution of one particle is 1 by 8. So, 8 when multiplied by 1 by 8 becomes 1 particle. That means a simple or primitive unit cell has only one constituent particle. It can either be atom, molecule, or it can either be ion. So, and the next type of system would be face centered unit cell, or it is also known as FCC arrangement. Face centered unit cell, also known as FCC arrangement. So, in case of FCC arrangement, let us have a diagrammatic view of the same FCC arrangement. In case of FCC arrangement, we have 8 particles at the corners, and we have 6 particles at 6 face centers. So, in case of face centered unit cell, we have 8 particles at the corners and we have 6 particles at face centers. We have 8 particles at the corners and 6 particles at the face centers. So, the number of particles would be 8 particles at the corners. So, 8 multiplied by 1 by 8, because the contribution of one particle at the corner would be 1 by 8, plus we have 6 particles at face centers and the contribution of one particle at face center would be half, 1 by 2. So, 8 multiplied by 1 by 8 would be 1 and 6 multiplied by 1 by 2 would be 3. So, it will be 4 particles. So, in case of FCC arrangement, we have 4 particles, either it may be 4 ions, 4 molecules or 4 atoms, it can be any one of the 3. So, in case of simple or primitive unit cell, we have only one constituent particle, and in case of face centered or FCC arrangement, we have 4 constituent particles, either it may be atom, it may be ion, or either it may be molecule, it can be any one of the 3. Now, the next one would be body centered or BCC arrangement. Body centered unit cell, or it is also known as BCC arrangement. So, let us have a diagrammatic view of BCC arrangement. Now, let this be a BCC arrangement or BCC unit cell. So, in case of body centered cubic unit cell, we would be having 8 particles at the 8 corners. So, these are the particles at 8 corners, and also we have a particle at the body center. The body center means where the gravity of the body is acting, or where the center of mass would be acting of the body, of the entire body. So, let us we have a body or a particle which is present at body center. This is the body center. So, in case of BCC arrangement, we have 8 particles at the corners and we have 1 particle at the body center. We have 8 particles at the corners and 1 particle at the body center. So, number of particle in case of BCC arrangement, number of particles would be, we have 8 particles at the corners and the contribution of each particle at the corner would be 1 by 8. So, the expression would be 8 multiplied by 1 by 8 and we have one particle at the body center, and the contribution would be complete 1. So, it would be 1 plus 1, that will be equal to 2 particles. That means, in case of BCC arrangement we have 2 particles, either it may be atom, it may be ion, or it can be molecule, it can be any. So, this was the calculation of number of particles in case of 3 arrangements, in case of simple cubic arrangement, in case of face centered arrangement, and in case of body centered arrangement. In case of simple cubic system we have only 1 particle, in case of face centered unit cell we have 4 particles, and in case of BCC arrangement we have 2 particles. We are not going to calculate the number of particles in case of edge centered or end centered arrangement, because there we will be getting the number of particle in fraction or in case of decimal, and we cannot have particles in decimal or fractions. So, we are not going to discuss about end centered or edge centered arrangement. We will be only discussing about 3 systems, that would be primitive or simple cubic arrangement, body centered arrangement, and face centered arrangement. We are not going to discuss about edge centered or edge centered arrangement. Now, next would be packing fraction. Packing fraction, which is represented by PF. Packing fraction, which is represented by PF. So, the packing fraction is, it is represented by a mathematical equation or a expression. PF is equal to volume occupied by particles upon volume of unit cell, volume of unit cell. This is the formula for packing fraction. This is the formula for packing fraction. Packing fraction is equal to volume occupied by particles upon volume of unit cell. This is the formula for calculating packing fraction. So, we are going to discuss about a ratio wherein we have volume occupied by particles, whatever would be the volume of particles, that will be placed in numerator portion, and the complete volume of the entire unit cell would be placed in the denominator portion, and the ratio of these two terms is referred to as packing fraction. And we will discuss about packing fraction of simple cubic arrangement, then we will discuss about body centered arrangement, and then at last we will discuss about face centered arrangement. So, we have to discuss packing fraction in all the three of them. Okay. Now, this is the formula for packing fraction. So, next would be calculation of packing fraction. Calculation of packing fraction. We have to calculate packing fraction in different cubic arrangements. Packing fraction. So, in this we have to discuss the first one, that is simple cubic system or primitive unit cell. Simple unit cell or primitive unit cell. Simple unit cell or primitive unit cell. This is the first one. So, let us have arrangement of this one. Now, in case of simple or primitive unit cell, we have particles only on the 8 corners. We have particles only on the 8 corners. So, let us have a particle over here. This is the particle which is present on this point, and let us have a particle which is present on this point, let be this one, and a particle which is present on this one. So, these two particles are touching each other and they let the radius, and one more thing, let the edge length be A, let the edge length be A and the radius of particle be R. Let the radius of particle be R. So, in case of this arrangement, this type of arrangement, let us have let this be arrangement of particle on the two corners. I have magnified the image so as to clearly represent the things, how they are superimposed on each other, but the particles are not so large in shape, they are quite small, but for sake of better understanding I will enlarge the structures of the particles. Now, let this be the particle situated on this point and this be the particle situated on this point. Let this point be A and this point be B. Let this point be A and this point be B. Now, we know that this distance is A, this distance is also A, and we can calculate the distance between this from A to B. We can calculate the distance from A to B. Now, when we will calculate the distance, we know let this be A, this be B and this point be C. See, so the distance AB would be equal to AC square plus BC square. So, we know that AC is A. So, it would be A square plus A square and it would be equal to 2A square, or it would be equal to root 2A. AB would be equal to root 2A. Let this be equation number 1, and we also know that AB is equal to 2R. We also know that AB is equal to 2R because the two particles are touching each other. This is R and this is also R. Let this be equation number 2. On equating equation 1 with equation 2, we would have root 2R is equal to root 2A, or we can have the value from here. It would be equal to 2R is equal to root 2A, or the formula of A would be 2 upon root 2R, or it would be equal to root 2R. It would be equal to root 2R. This is equation number 2. Okay. Thank you, class.